Okay, so properties of the logarithm. So firstly, I did highlight two properties last class that I'm just going to reiterate right now. So there were two things from last class, which I'm just going to restate. So this hopefully will look familiar. So we have one thing, log base b of 1, that is 0. And the second thing from last class was log base b of b, that is 1. Okay? That was from last class. And just here, I'm just going to put my conditions on b on the base. Remember, b is strictly greater than 0, and it's not 1. Okay? So that's just from last class. These are very useful properties. Okay? Yeah, so that's all I have to say about that. And I did show why these properties are true last class. All right, so you can look back on last class's lecture notes if you're interested. Okay, good. So now let's move on. So the first property we're going to talk about is the product rule. Product rule. Okay, so the product rule states, I'm just going to jump straight to the property. It is log base b of m times n. This is equal to log base b of m plus log base b of n. Okay, so what this property is telling us, I can split up the logarithm of a product. The product here is m times n. I can split up the logarithm of a product as a sum of logarithms. And by sum, I mean addition, log plus log. Okay, so let me just write that. So this is kind of just like the way mathematicians will phrase it sometimes. It's just the log of a product is equal to a sum of logs. Okay, so I hope you can kind of see the connection with the quote and the property itself. I have a log of a product, and that translates to a sum of logarithms, where each factor of the product is the input. Okay, so very nice property, very useful. So let's just go into some examples. Okay, we're just going to use this property. So so how about this? So how about log base b? So b is just going to be any non-zero base, that's not 1, of 5x. Log base b of 5x. Okay, so just for the first example or two, I'll be very slow and explicit. So the first thing you notice that 5x is the same as 5 times x, right? I'm not really saying anything new here. I'm just kind of realizing 5x as a product. It's 5 multiplied by x. Okay, so thus we get this. So we have log base b of 5 times x. Okay, now I'm going to use the property. I'm going to split this up into a logarithm of each factor, a sum of logarithms of each factor. So this will be log base b of 5, that's the first factor, plus log base b of x. And that's it. Okay. So that's pretty much the property. So you split up this product into a sum. So that went there, and that went over there. All right. So any questions? Any questions? All right. So we'll all right. So we'll do another. Do another. Okay. So how about this guy? How about log of 30x multiplied by 3x plus 4? Okay, so again, we want to realize this as a product, okay? What's being multiplied here? So firstly, I'm going to think of this as 30x multiplied by 3x plus 4, and that's how I'm going to split it up, all right? So this will be log, the first factor is 30x, and what you put there is now it's a plus log of the other factor. The other factor is 3x plus 4. Okay, so that went there, and that went there. Okay, so remember, this splits up as addition. Okay, that's really the key thing here. It splits up as addition, not as multiplication. All right, good. Now we can go a little further. So I'm just gonna this is really just for educational purposes. So just realize that 30x can be rewritten as 2 times 3 times 5 times x, right? I'm just kind of writing 30x in its prime factorization. So then look, this will be equal to log of 2 times, whoops, 2, 2 times 3 times 5 times x, and then the plus log of 3x plus 4, that just comes down. Okay, so I didn't do anything except rewrite the input of 30x into its prime factorization. And now, do you guys see that I can split up this first summand here, this guy, using the property, using the product rule. So this will be, here we go, log 2 plus log 3 plus log 5 plus log x. That was just this first yellow part, okay? That's what the yellow thing expanded out to that. And then the log 3x plus 4, that just comes down as is. Okay? So that will be that. That would be expanded as much as possible. Okay. All right, so any questions before I move on to the next rule?
So I have a question. So will it ever be shown as, let's say, 35, like log 35, and you would have to make it log 5 plus log 7, if you know what I mean?
Oh, yeah, I mean, that's just another example. Yeah, absolutely.
Oh, yeah, I mean, like, is it gonna have to, like, are you gonna have to break it up?
Oh, you're saying, are you going to have to factor the input as much as possible like I did
Yeah.
here? No.
Oh, okay.
I just did this for just an instructional purpose, just to highlight the property. You definitely don't need to split up this. So you're saying 35 is the same as 7, 40, 20. Yeah, 7 times 5. And then you're saying this would be log 7 plus log 5, right?
Yeah.
Yes, you would not, this would be unnecessary to me.
Yeah, that's not a good example because you can't factor 7 and 5 anymore either, but
But
yeah.
yeah, but
I
it
know
still
what you mean. Yeah,
highlights.
sorry about that.
No. That's actually still a good example because 35 is factorable. So it still can be used, but really to do this, I think would be unnecessary and would make the question more complicated. You know, you want to keep it as just log of a number. I just did this for instructional purposes, but this is not wrong though.
Thank you.
Yeah, you got it. All right, so as long as
For
everyone knows the property. Yeah.
sorry to interrupt, but for the highlighted portion where you did log 2 and just to confirm, is that all are those all log base 10?
Yes,
Oh,
absolutely. Yeah. So I have no subscript written, and that's understood to be log base 10. Yeah, thank you. So I'll just write that. Yeah. Good. So that was from last class. We have shorthand for log base 10 and log base E. Log base 10 is just written as log with no subscript. Log base E is written as ln. Good. All right. Excellent, excellent. So now we're going to move on to a quotient rule. Okay, so we have a product rule. We're going to have a quotient rule as well. And what you'll notice is that these all follow our rules of exponents. There's always an analog to our exponent rules, okay? Because exponentials and logarithms are inverses of each other, so you would expect that. So remember the the product rule of exponents, we have the quotient rule of exponents, now we have their accompanying or analogs in logarithms. So that's kind of the intuition. Okay, so what's the quotient rule tell us? So log base b, so the input ought to be a fraction. It ought to be a quotient. So m over n, okay? All right, what is this going to equal? Does anyone want to take a guess? Or does anyone know?
Would be m minus n, or log m minus log m.
Excellent, yeah, that is exactly it. Yeah, so now this splits up as subtraction. Good. This will be log base b of m minus log base b of n. Very good. So let me just kind of write it in that kind of informal mathematician language. So this would be phrased as the log of a quotient is a difference. So difference refers to subtraction, is a difference of logs. Okay. So that's kind of how you just say it. Is equal to a sum of logs. Yeah, is, yeah, I guess, is equal to a difference of logs. Okay. So good. Let's now just do a few examples with this guy. So we'll have log of 3x divided by 2. Okay, so we need to realize the input of the logarithm as a quotient, okay, as a fraction. Well, this is definitely a fraction. We have 3x in the numerator, and we have a 2 in the denominator. So we just have to plug it into this formula. So it's going to be log of the numerator, 3x, minus log of the denominator, which is 2. That's it. You just have to split up the top and bottom of your fraction. And now this would be optional, but does anyone see that you could actually split this up a little further? The log of 3x, that's a product now inside of that input. So you can go ahead there optionally and put in and use your product rule on that guy. So that'll be log of 3 plus log of x. Okay, so that was just this highlighted guy, and the minus log 2 will come down unchanged. Okay, so that would be an optional kind of thing. Okay. I would totally accept this. That would be fine as your final answer. All right, so are we all still good? Are we all still with me? All right, all right. Good, so now let's do a slightly more involved example, okay? Okay, how about this? Log of, okay, I'll have log of 15x multiplied by x minus 1. That whole thing divided by 3x plus 4. Okay, so the first thing you do is you just have to realize this as a quotient, okay, a fraction, something divided by something. So the numerator is, of course, 15x times x minus 1, and the denominator is 3x plus 4. Split it up like that first, using the quotient rule. So it will be log of the numerator. So just log of 15x multiplied by x minus 1 minus log of the denominator, okay? And the denominator is 3x plus 4. Okay, very good. So just like before, I will accept this as the final answer. That's fine. But just to kind of, just to reiterate and to kind of get these properties, you know, just to have some more practice with the properties, I can expand this guy a little more. Okay, so this highlighted summand, that can be expanded as such. Log 15 plus log x plus log of x minus 1, and then minus log of 3x plus 4. Okay? So I hope everyone can see how I got this. So that's going to be optional again. But I hope everyone can see it. So in this highlighted logarithm, I have three factors. I have 15, x, and x minus 1. Use the product rule in each of those guys, and you get log of 15 plus log x plus log of x minus 1.
I have a quick question.
Mm-hmm.
I've noticed kind of a pattern where we don't really expand upon when there's like an x minus 1 or a 3x plus 4. Like, could we break that down more as log of 3 plus log of x?
Okay, good question, but no, because this is not a logarithm of a product. There's not two things being multiplied here.
It's just, yeah.
X minus 1 is just a difference.
Okay.
So if I scroll up to the property, it only works if there's two things being multiplied in the input. So
Okay.
n times n. X minus 1 and 3x plus 4 are not of that form. They're not products. Okay. All right, good. So that will wrap it up for quotient rule. Okay. I don't think it's that that tough. It's very similar to the product rule, except there's a minus sign. Okay, the next one we'll do is power rule. So these all look very kind of similar to our exponent rules. And there's a reason for that. It's because, yeah, as I said earlier. Okay, so I'm not just going to state the rule this time. I'm actually going to do like a little motivation. Okay, so this is not the rule. This is just kind of like some motivational example. Okay, so let me just write that. Motivation. Okay, so you consider log of x squared. Okay, now I would like to use the product rule on this guy. So this would be the same as, I think you guys will agree, this is the same as log of x times x. Is that true? Because x squared is just the same as x times x by definition of whole number exponents. Okay, now what? I can use the product rule on this guy. Okay, so this will be log of x plus log of x. Okay, so far so good. And now these are like terms. Okay, these are like terms. They can be combined to be 2 log x. Okay. Aha, so do we see what happened here? Essentially, we took the power of the input of the log and it comes out as a coefficient. The 2 in the x squared got removed and was placed out as a coefficient. And that's the rule. That's the rule, okay?
How would you read that though?
Which one?
2 log x.
This would be 2 times log x.
Okay.
Or 2 log x. That works too. Yeah, so this is being multiplied. 2 times log x. Good. So here's the power rule. So this leads to the power rule. All right. So I just wanted a little motivation as to why this rule is true. This leads to the power rule, and here it is. So log base b of m to the nth power. Sorry, I want to write this neatly. Log base b of m to the nth power. That is the same as n times log base b to the mth power. All right, so hope everyone sees what's going on here. Really, you just bring this exponent in the input, it comes down as a coefficient, okay? That's what this rule is. Also very useful and very nice. All right, so we're gonna do some examples. Okay, so we will do natural log. So ln, remember that this is log base e. We'll do natural log of x to the third power. Okay, good. So now this 3 in the exponent, this exponent of 3, that can be brought down as a coefficient of 3. Okay, so this will now be 3 natural log of x. Okay, good. Next one. How about log base 5 of 5 to the 7th power? Log base 5 of 5 to the 7th power. Okay, so the input of the logarithm is raised to the 7th power, so that 7 can be brought down as a coefficient. So this is 7 times log base 5 of 5. Very good. Now, we can use the other property of log from the beginning of class. Does anyone remember what this bit will simplify to? Log base 5 of 5.
1.
Yeah, that's 1, exactly. So the answer will just, so that's 1. So the answer will just be 7. Okay, and this highlighted thing, that's 1, because remember, a log expression, you ask yourself, 5 raised to what power is 5? And that's 1, of course. 5 to the first power is 5. Very good. Okay, we'll do one more, and then we'll move on. Okay, so simplify log base 3 of 25. Okay, so I would like to use the power rule. However, the input of my logarithm is not an exponential. There's no exponents. It's just a number raised to no power. So how can I write, does anyone maybe see how I can write the input of the logarithm so it is something raised to a power? So I can use this rule?
You could use 1.
Okay, yes, that is always true. This is the same as 25 to the first power. But then I would just be bringing that in front, and that doesn't really change anything. But you're 100% right. But I'm looking for something a little different. So how can I write 25 as a power?
You can make it 25. You can make it 5 squared. Sorry.
Yes, exactly. So that's what I was looking for. But what Camille said is completely right as well. So I want to view 25 as 5 squared, exactly. So this will be the same as log base 3 of 5 to the second power. And now we can use that rule. Bring this power of 2 out as a coefficient. So this will be 2 log base 3 of 5. Okay, and the exponent is gone now. It's not still there. It has become a coefficient. Okay. All right, very good, guys, very good. So any questions on anything so far? All right, so we'll move on then. All right, so we'll talk about some things called the inverse properties. All right, so that's the next heading, inverse properties. Good, so I have said last class, and I even said it in the beginning of this class, that log base b and b to the x, those are inverse functions to one another. So what that means is if I compose the functions with one another, if I do log base b composed with b to the x, and in the other direction, if I do b to the x composed with log base b to the x, I will get the identity function. I will just get x back. Okay, so let me just kind of write that. So the first inverse property, it will be log base b of b to the x. So note here, this is a logarithm composed with the exponential. Okay, this is a function composition. And since they're inverses, the output is just the identity function x. Okay, so that's what it means for two functions to be inverses. It's mean when you compose them, you get the identity function, you get x. So this was on homework 7. Okay, there was an example where you did the two compositions and you got x. So I hope this is familiar. Okay, good. Now we do it in the other direction. You do b raised to log base b of x. So this is also the composition, but it's done in the reverse order of the previous one. This was also x. Okay, so the exponent here is log base b of x. Okay, good. And now let me just kind of write what I'm saying here. So these properties show that f of x equals log base b of x and g of x equals b to the x are inverses of one another. Right? Okay, so I will just show this first one. Okay, I will show the first one, this top bullet point, and I would like to leave it to you guys to think about why the second bullet point is true. All right, so maybe think about that later on. Why is this true? And it kind of follows really just immediately from the definition of the logarithm. Okay, so I'm just gonna look at the first one. Okay, so to prove the first one, okay, so what are we looking at here? So by the first one, I mean this first bullet point, log base b of b to the x equals x. I would like to show this. All right, so let's just start with it. So we have log base b of b to the x. Okay, now we have our power rule, don't we? I have the input of the logarithm raised to an exponent, so I can bring that down as a coefficient. This power of x can be brought out as a coefficient. So this is x times log base b of b. Okay, so this was by power rule. Okay, great. And now look at what we have left. We have x multiplied by log base b of b, but that is 1. So so this is just x times 1, which of course is just x. All right, so that's the proof. And again, I would like to leave it to you guys to think about why the second one is true. All right, I think it's just a nice thing to think about. All right. Good, good, good. Okay, so why do we care about these inverse properties? Well, meaning what are they useful for? So, well, we can use these properties to find inverses of exponential functions. Okay. So let's do one example. Let's do one example. So the question will be to find the inverse of Find the inverse of y equals 2 raised to the 3x minus 5 power. Okay, so this is definitely an exponential function because I have a base that is just a constant, it's the number 2, and the variable is in the exponent. So this is definitely an exponential function. Okay, so this is how we do it. It's the same procedure as when we found inverse functions on homework 7. So the first step is to swap x and y. Swap x and y. So what will that give us? X is equal to 2 to the 3y minus 5. Okay, good. Next step will be apply. So now you look at the base of the exponential here, and the base is 2. So you apply log base 2 to both sides of this equation. Okay, so you apply log base 2 of x to both sides of the equation. Okay, so what does that look like? So if I apply log base 2 to the left side, I will just get log base 2 of x. Log base 2 of x. Now apply log base 2 to the right side. I get log base 2 of 2 raised to the 3y minus 5 power. Okay, so I hope everyone sees what I did. I just applied the log base 2 function to both sides of the equal sign. And why did I use log base 2? Well, the reason is because I can use the power rule on this. So this is now, apply power rule on the right side. So let me just write that. On the right side. Okay, so the left side will stay exactly as is. So it's log base 2 of x. This is equal to, so I'm going to bring this exponent of 3y minus 5 outside as a coefficient. Okay, that's the whole point of this. That's why I applied log base 2. So that will be 3y minus 5 times log base 2 of 2. Okay, good. And this is very nice because this factor, log base 2 of 2, that's 1. Okay. Okay, so now solve for y. Now solve for y, and that will be your inverse. Okay, so we will have, we have 3y minus 5 is equal to log base 2 of x. Okay, I just flipped the equation over and I rewrote log base 2 of 2 as 1. Good, now just algebraically manipulate this so we can isolate y, which means just solve for y. So we will have 3y is equal to log base 2 of x plus 5. And now divide both sides by 3. This will be log base 2 of x plus 5 all over 3. And you're done. Okay, so that's pretty much it. You will see an example like this on homework 8. It's going to be just like this. So just you can use this question as a guide as to how to solve the one on the homework. All right, so any questions about what I did? Does everyone see why the steps work and why? Yeah, so just please let me know.
Is it always gonna be apply log base 2? Or do you use the same base as what it gives you?
That one. Use the same base of the exponential. Here, the base of the exponential is 2, so I will apply log base 2 to both sides. Yeah. And the reason being is so that this guy comes out to 1. That's really, it just makes it nicer. Yeah. But you don't have to use log base 2, because this power rule could have been done no matter what base I applied to both sides. But you like to use log base 2 because this factor will just reduce down to 1. That's really it. Good, good. All right, very good. All right, so what we did earlier in class is we expanded logarithmic expressions, but now let's go in reverse. Let's, given a sum of logs, let's like condense them. Let's go in reverse now. So let's do that. Condensing logarithmic expressions. Okay, so that's the heading here. Condensing logarithmic expressions. Okay, so let me just kind of type what we'll be doing here. So using properties of logs, we can rewrite sums and differences of logs as a single logarithm. Okay, so that's the whole point. We're going to be given like a sum or difference of logs, and we want to condense it into a single logarithm. So we're going to be using our product rule and quotient rule in reverse. That's all. All right, so let's just kind of see what this looks like. So really, we're not doing anything new here. Okay, this is really just our previous rules, just under a different context. So, example, write log 5 plus log 3 minus log 2 as a single. So that's kind of the important part, as a single logarithm. Okay, good. So what we can do first is we can think of this guy. This looks like a sum of logs. This looks like log base m, log of m plus log of n, and we know that's the same as log of m times n. So this guy that I have underlined, that's the same as log of 5 times 3. Okay. So that's the highlighted portion. The highlighted portion has went to log of 5 times 3. Okay, so we're just using that product rule in reverse now. I hope everyone sees that. And then the minus log 2 will come down. Okay, good. Now let me just do that 5 times 3 inside of the input. So this is log of 15 minus log 2. Okay, good. Now, doesn't this look like the right-hand side of the quotient rule? This is the same, we have a difference of logs. That's the same as the log of the quotient. So this is log of 15 over 2. Okay, so we didn't do anything new in this example. We are just going in the opposite order. We're condensing now. We're going from an expanded form into a single logarithm. All right, so any questions? So from here to here, let me just clarify, this was the quotient rule. All right, so if everyone's okay, I will do, let me see. Okay, I will do one more example under this heading here. So, example. Okay, so the question will be to condense log base 2 of x squared plus 3 log base 2 of xy squared. Okay, so first things first, we can't use the product rule immediately, and the reason being is because of this coefficient of 3. Okay, so remember the product rule, log of mn equals log of m plus log of n. Well, that requires all of the coefficients of log to be 1. We have a coefficient of 3 here. So that doesn't work yet. So we need to do something. So does anyone, so first let me just write that. And then maybe as I'm writing it, think about how we can get rid of this coefficient of 3. All right, so think about it as I just write that.
So you can't solve it like that?
Just hold on one second. Let me just write this down. We need to get rid of the coefficient of 3 before we can use the product rule. So let me scroll up to the product rule very quickly. Okay, look at the product rule. I need the coefficients in front of these guys to be 1. That's how the product rule will work. I need 1 times log m plus 1 times log n. Okay, but look what I have down here. I have a coefficient of 3. That's a problem. We cannot use our product rule. However, we can get rid of it and make it a coefficient of 1. And does anyone have any ideas?
I actually have a question really quick. For if they both had the same coefficient, would it work? Like even if either were like 0 or 1, but like both of them were 3, would it work?
Yes, right. Okay, yeah. So if they were both 3, you could factor a 3 out from both terms. And then they would both have a coefficient of 1. So what you're saying would be like, it would work, but that's a very special kind of rare case. So it would be like 3x plus 3y, where x and y are the logarithms. And that would be the same as 3 times x plus y. And then you can use the product rule here.
Okay, so it would end up in the same way. Okay, thank you.
Yeah, but yes, that would work if the coefficients were exactly the same. But we're not in that situation. That's like a rather convenient and special case. But yeah, good ideas. So does anyone see? Oh, I see something in the chat here. Let's see. Why can't we add them? Yeah, so Saeed, what I was saying before is that the product rule, you need a coefficient of 1 in front of each summoned in order to use the product rule. We have a coefficient of 3 here, so that doesn't work. So does anyone have an idea? Do we have some rule that kind of can mess with coefficients? Can we get rid of this coefficient? Can we place it somewhere else?
Can we divide it by 3?
I can divide it, but then I'm left with a 1/3 in the first guy.
Yeah.
But it's not a coefficient of 1. So,
Isn't it the power rule?
Yeah, exactly. So, right, so remember the power rule, we can bring the coefficient up here. Exactly. So we're doing the power rule in reverse now. Very good, very good. So you use, very good. So we use power rule. Okay, good. So the first summand will stay exactly the same. So that'll be log base 2 of x squared. Now I can bring this coefficient of 3 as a power. Okay, and this power will be raised to the whole input. Oh, it's not plus, sorry. It's gonna be, it's not equals, it's plus. So plus log base 2 of, so be careful now. It's going to be the whole expression xy squared, that whole thing raised to the third. Okay, so the power of 3 went there. No longer a coefficient. So Saeed, what did you say here? You said by maintaining the same logs, as in having only a 1, is that like keeping the same bases? So it is different. We needed the bases to be the same in order to apply the product rule, and in this case, they are already the same. So we were okay in that. But you know what? You bring up a good point. If this log base 2 here was maybe like log base 3, and this was still log base 2, the product rule would not work. We would be done at this point. You can only use the product rule and quotient rule with the same base. Yeah. Okay. Good. So we have successfully gotten rid of this coefficient of 3. Now, we are of the form log m plus log n. I can rewrite this now as log of a product. So this will be log base 2 of x squared multiplied by xy squared to the third. Okay, so I hope everyone sees what happened here. That went there, and that went right there. So this is the product rule in reverse, and we can do better. So now let's use some old stuff, some old properties of exponents. Now, look, I have a product raised to a power. I can distribute this power of 3 to each factor. So this would be x squared times x to the third times y to the sixth. Okay, so does everyone see how this went to there? I use the power to a power rule, and then y squared to the third power is y to the sixth. Okay, good, almost done. This will be log base 2. Now you can use the product rule of exponents on x squared times x to the third. That would be x to the fifth times y to the sixth.
Could you explain this one again? I'm sorry.
Yeah, like from which part? Like the whole thing or from down here?
Just the second one.
Right, so like from where are you starting to get confused?
Just the part where like what is the part when you're combining them? So x squared times x squared parentheses 3.
Yeah, okay, so right here, so you're talking about kind of from here to here. So this is, so I'm gonna write that again. So this is like a side. So log base 2 of x squared plus log base 2 of xy squared to the third. Okay, so this looks just like log base 2 of m plus log base 2 of n. Okay, we have log base 2 of something plus log base 2 of something else. And by the product rule, this is the same thing as log base 2 of m times n. So that means I want to multiply these two inputs together and write it as one logarithm.
Okay.
So
No.
this will be log base 2. No, I will multiply x squared by this input, xy squared to the third.
Gotcha.
You get that? And now from this point onwards, it was just properties of exponents.
Thank you.
Yeah, no problem. So that's product rule. Okay, good. So any other questions? Okay. All right, good. So we have the final thing for the night. It's the change of base formula. Okay. So very quick, change of base formula. Okay, good. So let me just kind of write out just a quick description of what the change of base formula is. Okay. So sometimes, perhaps in the old days, calculators were only able to calculate. Now let me write. So calculators are only able to calculate log base 10 and log base e, ln. Okay. So that was like, I guess, a long time ago. So given some other base, say b, we sometimes need to convert it to base 10 or base e. Okay, so that's pretty much the motivation. There are some calculators, I think, yeah, so there are some calculators out there, they only have log base 10 and log base e. So if we want to put other bases into that calculator, we would like to convert to base 10 or base e so that calculator can calculate those logarithms. Okay, and it's just a formula. Okay, so here's the formula. Okay, good. So here we go. To convert log base b to log base n, this is what you do. So log base b of m, this equals. So we are given log base b, the right side will now be in terms of log base n. This is what it is. It's log base n of m divided by log base n of b. And that's it. That's the formula. Okay, so this m went here, and this b went there. And now notice that the right side is written completely in terms of base n. Okay, so now let me just write that quickly. Notice how the right side is all base n. So as I said, usually we will take n to be 10 or n to be e. So we can convert to base 10 and base e respectively. Did I really spell that wrong? Yeah. Okay, so that's pretty much what we're going to do. We're going to convert from log base b to log base 10 or log base e. That's really the most popular uses of the change of base formula. Okay. All right, so here we go. We're going to do 2 examples and then we will be finished. So example. Write log base 5 of 3 in terms of natural logarithms. Okay, and that just means in terms of base e, okay? All right, so really there's not much else to do here except to just apply the formula. So here, b is 5, capital M is 3, and n, which is the base we want to convert to, is e. Okay, so using the formula. So I'm just going to directly plug in these values into the formula. Log base 5 of 3. This will be log base e of 3.
M is the output, correct?
Divided by log base e of 5. What was that?
M is the output, correct? When you apply the logarithm.
No, M is the input of what you're converting from.
Okay.
It's log base b of m. So we're given that. We want to convert to log base n. Okay. Good. So it equals this. However, we do have shorthand notation for log base e. Okay. You really will very rarely ever see log base e. Remember, we write that as ln. So that'll be ln of 3 divided by ln of 5. Okay. So it's not wrong to write log base e, but it's just unconventional. Okay. So this is the preferred final answer, ln of 3 divided by ln of 5. Good. We're going to do one more where we convert to log base 10, and then we will be finished.
Does that calculate to anything? I mean, or
Oh, nothing
no.
nice. Yeah, like not like a whole number or anything.
Oh.
Yeah, I'm not, off the top of my head, I'm not sure what this would be. Yeah, probably something nasty.
Much.
Okay, good. Last example. Now, let's convert log base 7 of 8 to base 10. Okay, so yeah, that, as I said, that these are going to be our primary uses for the change of base formula. We'll convert to base e and base 10 because historically that's what the change of base formula was used for. All right. Okay, good. So let's just kind of lay out our data here. So here, the base given to us is 7. The input is 8. And n, which is the base we want to convert to, that's 10. All right, so we'll just go straight to the formula. Log base 7 of 8. This will be, it's log base 10 of m, which is 8, divided by log base 10 of the original base, which is 7. Okay, good, but remember, we do have shorthand for log base 10. So you will usually see this written as just log of 8 divided by log of 7.